2024, German scientists uncovered a dataset so shocking that it forced NASA to convene an emergency meeting. Our solar system is racing through the Milky Way at a speed 37 times faster than previously expected. This is not science fiction. It is the conclusion drawn after the LOFAR radio telescope observed tens of thousands of galaxies. Even more unsettling is this: no one knows what is pushing us forward. After nights of non-stop calculations, physicists reached a disturbing conclusion. If this speed is real, then everything we've learned about the universe over the past 100 years may be wrong. Imagine sitting on a cosmic high-speed train, with no idea who is driving, no idea where it's going, and with brakes that don't work. That is our situation right now. One astronomer quietly said something chilling in private. We may have never truly understood our position in the universe. So how was this number measured? Scientists used a method called dipole anisotropy. In simple terms, when you're moving rapidly through the universe, galaxies in the direction of motion appear denser, while those behind you appear sparser. It's like running through a rainstorm. The raindrops hit harder from the front. LOFAR observed tens of thousands of distant galaxies, and found that this density difference was 37 times stronger than theoretical predictions. A team from Bielefeld University in Germany repeatedly checked every possible source of error. Instrument failures, observational bias, data processing issues. All were ruled out. The signal remained. The paper was published in Physical Review Letters, one of the most prestigious journals in physics. So what does 37 times actually mean? It's like thinking you're driving at 100 kilometers per hour, only to suddenly realize the speedometer reads 3,700 kilometers per hour. Some physicists privately calculated that, if this speed is real, we are moving through the universe at over 600 kilometers per second. In the time it takes you to blink, Earth has already traveled several thousand kilometers. The question is, who gave us this speed? The first possibility is deeply unsettling. Maybe our original estimates of the solar system's motion were wrong from the very beginning. You see, astronomers measure all cosmic motion relative to a reference frame, just like GPS needs Earth's position as a baseline. If that reference frame itself is skewed, then everything built on top of it, galaxy distances, expansion rates, dark energy distributions, would need to be recalculated from scratch. This isn't about tweaking a few parameters. It would mean rewriting the foundational logic of cosmology. The second possibility is even more radical. Standard cosmology rests on a core assumption that the universe is uniform on large scales, like a perfectly stirred cup of coffee. But the LOFAR data suggest the universe may be more like bubble tea that was never mixed, with pearls clumped densely in some regions. If this is true, it means the universe's evolution after the Big Bang was far more chaotic and unpredictable than we thought. These enormous matter clumps would generate additional gravitational effects, pulling the entire solar system in a preferred direction. There's a crucial detail here. This is not the first time such anomalies have appeared. Earlier studies of quasars and infrared galaxies hinted at similar directional asymmetries, but the datasets were too small to be conclusive. Now, with tens of thousands of galaxies observed by LOFAR, those scattered hints have formed a coherent chain of evidence. When multiple independent studies point to the same conclusion, it becomes very hard to dismiss it as coincidence. But there is a third possibility, and it is the most subtle of all. Maybe the issue isn't our motion, and not the structure of the universe, but the radio galaxies themselves. Radio galaxies are special systems with supermassive black holes at their centers, emitting powerful radio jets. If their formation and evolution differ from ordinary galaxies, their distribution could naturally produce a stronger dipole signal. In that case, the anomaly would reflect the complexity of galaxy evolution, not a cosmological crisis. Right now, the biggest mystery is this: we don't know which explanation is correct. But one thing is certain: within the next 5 years, we will know. Because humanity is about to enter a golden age of observation. First, there is the Square Kilometre Array, SKA, currently under construction in Africa and Australia. When completed, it will be the most powerful radio telescope ever built, with sensitivity several times greater than LOFAR. If the dipole anomaly still appears in SKA data, we can be confident this is not an instrumental artifact, but the universe itself trying to tell us something. The Vera Rubin Observatory is equally critical. Over the next decade, it will map the entire southern sky and record the positions of billions of galaxies. Its data will reveal whether this anomaly exists only in radio galaxies or across all galaxy types. The Euclid Space Telescope will provide infrared observations, perfectly complementing LOFAR's radio data. Together, these three instruments are like giving the universe a full-body CT scan, examining it from different angles and wavelengths. By 2028, when SKA begins full operations, we will have our answer. You might ask, does this affect everyday life? In the short term, no. Earth won't fly apart because the solar system is moving faster. The seasons will still change as usual, but scientifically, the impact could rival the discovery of cosmic expansion itself. Think about it. Humanity spent centuries building modern cosmology. From Newton's law of gravitation, to Einstein's general relativity, to the Big Bang theory. This framework explains galaxy formation, cosmic expansion, black holes, almost every major question about the universe. And then LOFAR comes along, and reveals a crack in the foundation. The building may not collapse, but the crack reminds us that our understanding of the universe may still be profoundly incomplete. That is what makes science so captivating. Just when we think we've grasped the truth, the universe finds a new way to tell us, you're not even close. Every such discovery is another leap forward. In humanity's understanding of the cosmos, there's another angle worth considering. If the solar system really is moving at such extreme speed, what force is driving it? The Milky Way's gravity isn't enough. Dark matter could be involved. Or perhaps, somewhere beyond what we can see, there exists an even larger cosmic structure, exerting influence over the entire local group. Scientists have proposed something called the Great Attractor, a massive structure hundreds of millions of light-years away, with enough gravity to pull thousands of galaxy clusters. Our galaxy is accelerating in that direction, but whether the Great Attractor alone can explain LOFAR's anomaly remains uncertain. Some theories suggest there may be structures even larger than the Great Attractor, farther away, pulling on us. It brings to mind an ancient question. The turtle carries the elephant carries the earth, but what does the turtle stand on? Perhaps behind the Great Attractor lies an even greater attractor, and behind that, something larger still. The structure of the universe may be orders of magnitude more complex than we ever imagined. This discovery also forces us to revisit a philosophical question. What is humanity's place in the universe? Centuries ago, we believed Earth was the center of everything. Then we learned Earth is just a planet. Then that the solar system is a small corner of the Milky Way. Then that the Milky Way is merely one member of the local group. And the local group is only a tiny part of the Laniakea supercluster. Again and again, we've learned we are not special. Now LOFAR tells us, we may not even know how fast we're drifting through the cosmos. This sense of uncertainty is humbling and exhilarating, because the unknown means there is still room to explore. It means humanity's journey is far from over. One astrophysicist once calculated that, if we are moving at 600 kilometers per second, then over the 13.8 billion years since the Big Bang, the solar system would have traveled more than 260 billion light-years. Of course, the number is meaningless, because space itself is expanding, and distance in cosmology doesn't work the way we intuitively expect, but it gives you a sense of just how wild our motion through the universe truly is. The next 5 to 10 years will be the verification period. SKA will be fully operational by 2028. The Vera Rubin Observatory has already begun test observations. Euclid is sending back data. Together, they will tell us whether LOFAR's anomaly reflects the universe's true structure, or the limitations of our methods. Whatever the answer, one thing is certain. The universe is more complex and more mysterious than we imagined. We thought we had drawn a map of the cosmos. Now we realize it may not even qualify as a sketch. And that is precisely what makes scientific exploration so thrilling. Tonight, when you look up at the stars, remember this: the planet beneath your feet is carrying you at an astonishing speed through the Milky Way. We don't know where the destination is. We don't know how long the journey will last. But one thing is clear. We are witnessing another turning point in humanity's understanding of the universe. Perhaps one day, when we finally understand why the solar system is racing so fast, we will also uncover deeper laws governing cosmic evolution. Or perhaps we will uncover even more mysteries, and realize that the depth of the universe far exceeds the limits of human intelligence. This is the story of the solar system's cosmic sprint, a story about speed, about the unknown, and about humanity's endless curiosity. And this story has only just begun.